Okay, so these are our molar volume notes. Okay. Okay, so this is another part of mole conversions, but it's going to volume. So some things we can't measure in grams, kind of like gases, okay? Gases would be really hard to measure in grams because they are a gas, okay? We can't scoop them out, but we can measure a volume. So we also have a conversion so that we can do gases. We also have a conversion from moles to something called, remember, as liters or milliliters, okay? And so these are mole conversions. That convert, okay, moles to liters, okay, which is a volume, okay. These are mostly used for gases, okay, because it's really hard to measure the grams of a gas. So a lot of times we will do volume, okay. And these conversions are at what we call STP. Okay, so I'm going to define what STP is for you guys. It is a short way to say standard temperature and pressure. Okay. And so what this basically is telling us that we're going to have a standard temperature and pressure because gases can change based on their temperature. When they get hotter, they change their volume. Okay. And when they have different pressures, like they're either condensed or give more space, they have a different volume. Okay, because they can move around a lot more. So when we're talking about this conversion, we're always talking about, and you'll hear me say it, we're converting at STP, which means standard temperature and pressure. And that's a defined temperature and pressure. And so our temperature for STP, okay, is 0 degrees Celsius, okay? So that's the temperature we're at. And our pressure is what we call 1 atmosphere. Okay. And so when we're converting back and forth here, we're always saying we're always at 0 degrees Celsius and 1 atmosphere. In this class, you will always be at STP. Okay, no matter what. Most of them do say STP, but as you get into higher chemistry, then that's when they start throwing in non-STP stuff, okay? And so you have to have it at standard temperature and pressure to do this conversion, okay? And the conversion we have is 1 mole equals 22.4 liters, or you can write it, there's 22.4 liters in 1 mole of any gas, okay? But this also equals, remember, 6.02 or Avogadro's number times 10 to the 23rd atoms or molecules. Okay, so all of that is the same. In 22 point, just like we talked about anything on the periodic table, when you take its atomic mass, it's going to equal 602 hexillions atoms or molecules, which also equals 1 mole. Same thing here. So we assume in 22.4 liters of any gas, there's going to be 1 mole, which is also tells me there's 602 hexillion atoms or molecules in there. Okay? All right. So the steps pretty much are the same. Okay? As we did before. So the steps are the same as we did before, but instead of using molar mass, we're going to use our molar volume. Okay? So we will box the given. We will annotate our question. We will circle. Yep, thank you. Circle the want. Okay? Then we will write our given. We will set up the train tracks. Okay. And then on top of the train tracks, write the units and formula, okay, and chemical formula of the want. And then on bottom of train tracks, write units and chemical formula of given. Okay. And our last step, okay, are two more sets. Write numbers for molar volume in train tracks. And last step, anything on top, what do you do with those two numbers? Anything on top, you multiply by. Anything on bottom, you, what do you do with it? Divide by. Good. Okay. So, same steps, except now, okay, now we're going to add in a molar volume instead, okay? Questions so far? Okay. We're going to do some examples, okay? Okay. All right. All right. So the first example we're going to do is going to go from moles to volume. Okay. So it says, what is the volume of 1.5 moles of chlorine gas? All right, Cl2, because remember that's one of our Hofbrinkel diatomics, so it gets a subscript of 2. Okay. So now we're going to box our given. So we'll box. Here's our number with our units and our formula, Cl2. We will circle what we want. What are the units of volume? Units of volume is what? Is what? Liters, okay? So we're going to write our given 1.5 moles Cl2. We're going to do our train tracks. Okay. The units of my want go on the top, so whatever I want. So you told me the units of volume is liters. My formula that I'm converting from is chlorine gas, or Cl2. The units of my given go on the bottom. So I'm going to go ahead and add my units, moles of chlorine gas. That's my formula, Cl2. Okay. Now I will add in my numbers from my molar volume. And remember, 1 mole equals 22.4 liters. Never changes. So 1 mole, 22.4. These numbers are both on top. What am I going to do with those numbers? You know what? Multiply them, okay? And when I multiply them, how many decimal points am I going to go out? 1, 2, 3. How many am I going to put? Just 1. 1 and 1, so I'm just going to do 1. So when you multiply these out, you should get 33.6 liters. You add your units, because moles will cancel moles, of chlorine gas. And you're done. Questions on that one? Okay, let's go the other way. So now let's do an example. Of volume 2 moles. Okay? So our question on this one is going to be how many moles is 50.4 liters of methane gas. That's CH4. Okay. All right. So our first step is to go ahead and box our given. What is our given here? Right, 54 liters of methane gas. What do we want? Moles. So I'm going to write my given again, 50.4 liters of methane. Draw my train tracks. If I'm talking, you're not talking. What are the units that go on top? My given or my want? What goes on top? Circle or box? The want. And my units are moles. And we're going to stay within methane. Okay? What units are going to go on the bottom? Liters. CH4. Okay? Remember, when you're going through this molar volume, you're using your 1 mole equals how many liters? 22.4. So 1 mole, 22.4. Now it's on the bottom. What do I do with these numbers? Divide. How many decimal points am I going to go out? Just 1. So when you do that, you should get 2.3 liters. Because liters, or moles, sorry, moles, see? Liters cancels liters, 2 moles of CH4. Okay? Questions on that one? We're going to take it one further step today. We're going to mix both of them together. So we're going to do one example where we're going to go from grams out to liters and then liters back to grams. Okay? So now I'm going to take that first mole conversion you guys practiced and mix it with molar volume. Okay? Questions so far? Hopefully not too bad, right? No, you've done it once or twice. Okay? All right. So now let's do an example of grams to liters. Okay. So this will be my third example. Okay. So let's do how many liters in 42.3 grams of oxygen gas. Okay, so one of the things you have to remember is whenever you see grams in something, what do you have to calculate to go from grams? What's the only thing in grams? Does molar volume have grams in it? No, what's that other conversion I guys taught you that has grams in it? The molar mass, right? So you're going to have to calculate a molar mass. Whenever you see grams in something, you have to calculate a molar mass, okay? So we're going to calculate our molar mass of whatever we're doing. So we're going to do the molar mass of oxygen. And there's 2 oxygens, so 2 times 16.00 will give me 32 grams per mole, okay, of O2. So now I'm going to box my given, 42.3. I'm going to circle my want, liters, okay. Now you're going to see it take 2 train tracks, okay. So this is going to end up with 2 train tracks instead of just our 1. So we're going to go ahead and put in our given. Now, when you add a train track, you have to know where you're starting. So I'm starting with grams. Is there a direct conversion from grams to liters? Did I ever give you one? No. Remember, we're always going to have to go through the mole, okay? The mole is that one that brings everything equal to the same amount of atoms and molecules. So when we convert anything, if we're at grams, if we're at liters, we've got to go through the mole, okay? Which means I'm going to take this one, okay, and I'm going to have to convert grams back to moles. So my first step will be go through moles of O2. But I'm beginning at grams of O2. Okay. So now I'm going to have to add in here my molar mass. So remember the number goes with 32 to 1 mole. But I'm not there yet. So there's 2 ways you can do this. You can convert straightforward from grams straight to moles and then moles to liters. I'm going to show you how to do that 2 steps like that. Or you can do it all in 1 step, which is what I'm doing here, setting up 1 train track, okay? I'm going to show it both ways each time. You choose for now which one is best for you, okay? Which one makes the most sense to you, okay? So what I would do here, so this, remember, this is the same as if I set this up. And it's on the bottom, so what do I do with those numbers? I divide. So I will take 42.3. I didn't calculate that one out yet. 42.3 divide by 32. And that should get me, I'm going to round it to 2 decimal points. 1.32 moles of O2. Grams cancel grams. Then you could take, and I'm going to show you how to do it all in 1 step, but if this makes sense, then you take your 1.32. This now, whatever you get in the first one is now your given. okay? And we want to go to liters, but my given is in moles of O2. And how many liters in 1 mole? How many liters in 1 mole? 22.4. It's on the top, so what do I do with those numbers? What do I do with them? Multiply them. So 1.32 times 22.4 will give me, and I have 2 decimal points there, so I'm going to do 2 decimal points, 29.57 liters of O2. Okay, moles cancels moles. So that is what we call a 2-step. Okay, how we doing with that one? Yeah, okay. So convert to moles and then back out to liters. There is, for those of you that are really don't want to do that much writing and are really good at math, you can do it all in one train tracks. And all it does is it takes this one and puts it over here. So notice I went from grams, right, to moles. I wrote exactly what I wrote here, right? But then in my next one, because my grams will cancel, now I'm in moles. Okay? And I want to go to liters. So what I circled was liters of O2. And I am now in moles of O2. And how many liters in a mole? Okay. Notice all this one does is it takes this conversion, puts it there, takes this conversion, puts it there, all in one shot. Okay. If that is not something you want to think about today, that is fine. You can still do it this way. Okay. Then we just go across and moles will cancel moles. So that's a double check, okay, to leave my liters. Anything on the top, you multiply by. Anything on the bottom, you divide by. Do you have to do it, divide or multiply by 1? Does 1 do anything? No. So you can ignore the ones, okay? So you take 42.3, divide by 32. Multiply by 22.4 and you will come out with the same thing. Okay. Okay. Same thing. It's just writing it all in one train tracks instead of splitting it up in 2. Eventually you will get to those double train tracks. Okay. But for now, since we're doing just mole conversions, if you want to split it up like this, go for it. Okay. That's fine too. As long as you get to the right answer, okay? Questions on that? Okay. Now, let's practice going from liters to grams because you're going to have to do those too. Okay? And just to kind of simplify it, we're going to do the same formula, but we're just going to flip it. And you'll see how it's just the opposite, okay? So, let's go to how many, okay, grams, okay, in 29.57 liters of oxygen, okay? So notice again, when I box, so I'm going to box my given. I'm going to circle my want. If you ever see grams on either in your box or your circle, you're always going to have to calculate the molar mass, okay? Because that is the only way to get through grams. So again, molar mass of O2 is 2 times 16.00, which is 32.00 grams per mole. I'm going to show this split up way. So since we're in liters, we're going to need to go back through the mole to get back to grams. Just like when we were like at centimeters and we had to go to like decimeters or kilometers, you had to go through the meter to get out there, okay? So we're going to write our given 29.57 liters of oxygen, train tracks. We're going to write what we want. Well, we can't go straight to grams, so what we're going to do is we're going to put it through the mole. Okay? And the units of my given are liters of O2, and in 1 mole there's 22.4. So that number is on the bottom. So what do we do with those numbers? Gonna what? Divide or multiply? Divide. So you'll do 29.57 divided by 22.4. And if we're going to round it, we're going to round it to 2 decimal points, so I get 1.32 moles of O2, because liters cancels liters. Then I'm going to take my moles. That's now my given, my answer. And now I'm going to convert to grams. Remember, molar mass is what gets us to grams. So the units that I circled here, this will be my N1, will be grams of O2. My given this time is moles. And from my molar mass, it tells me there's 32.00 grams in 1 mole. These two numbers are on the top, so what do we do with them? What do we do with those? Multiply. So we're going to take 1.32 times 32. Should get you. Okay. All right. Questions on those 2 steps. That's what we call a 2-step. You got to go 2 times, right? Okay. All right. Last example that you'll have to practice through is going to atoms or molecules. And it's going to take, everybody should have a calculator. Everybody have their calculator out? There's going to be a little training with your calculator how to do this fast way, okay? We're going to go to atoms and molecules. So we got to know how to put that 6.02 times 10 to the 23rd in your calculator, okay? All right. So we're going to go from okay, moles to atoms or molecules. Okay? So, last example, here we go. Okay? How many moles are in, let's see, hold on, 1.202 times 10 to the 24th atoms of hydrogen. Okay. So the process is the same, it's just the conversion is different, right? So given 1.02 times 10 to the 24th and want. Since I have no grams here, I don't have the calculated molar mass, okay? Only if you have grams in your circle or your box are you going to calculate a molar mass, okay? So, remember the conversion here is there's 6.02 times 10 to the 23rd atoms or molecules or whatever they want to call in 1 mole, okay? So, we're going to write our given and we're going to learn how to put this into our calculator. 1.202 times 10 to the 24th atoms of H2. Draw our train tracks, the same as we've been doing. Okay. We're going to write the units of our want, or what we circled on top. So I want moles of H2. The units of what I boxed or my given go on the bottom, so atoms of H2. This is the conversion I'm going to use. So in 1 mole, there are 6.02 times 10 to the 23rd atoms, okay? So this is on bottom, so what am I going to do with that number? You're going to divide by it. So now let's learn how to put this in our calculator. I want everyone to look at your calculator. Mine's a little different, but I'm going to use my class one. Okay? I have mine that I like, but, okay? You're all looking for a button that says big E, big E. So I'm going to show you on on these calculators that are mine. This is a school one. So right above this X to the -1, you can see, hopefully you all see a big E, big E. My other one, if you have one of the other type of versions of TI-30X, has this EE button. Okay? Does anyone not have an EE button on their calculator? Everybody find their EE buttons? Yes? Okay, what that is an exponent button. It makes your life a whole lot easier. Okay, so if you're on my calculators, take this away for a second. What you're going to do, so we're going to put in 1.02. So put in 1.202, just like this. On my calculators, because it's blue, it's a second function. So you're going to push second, the blue button, and then you're going to press the button X -1, and you should have a little E show up, okay? Some of you might just see your little number go up higher, and you're going to put in the exponent, which is 24, just like that, okay? Everybody okay so far? Then you're going to press, we're going to divide by this number, so you can press divide. And then we're going to put in Avogadro's number. So 6.02. Again, press the second and the EE and put in the exponent of 23. So what that E does is it puts in the times 10 for you. Okay? And then just press equals. And you should get a number. Right? You should have got 1.99. Okay? When you guys, we'll see in a minute, I'll do a quick one where we go the other way and how you would read that, okay? So our answer here is going to be, and we're going to go, we have 3 decimal points here, so we got to go all the way out to 3 decimal points. We're going to go to 1.997, and atoms cancel atoms to leave moles of H2. Did everybody get their calculator to work? Yes? Anyone not get their calculator to work? Because I am happy to show you again and again. Okay? All right, we're going to practice. We're not going to do the example, but we're going to practice and see what it reads. Okay? So, if I gave you, and I'm just going to write the question. You can write it if you want, but I'm going to say, okay, just so that you guys can see. We went to moles to atoms, so now we're going to go from atoms to moles. So if I had, I just have to think of a number, 2.16 times 10 to the 24th atoms of oxygen is how many moles? Okay? So again, here's my given, here's my want. So I'm going to write my given, 2.16 times 10 to the 24th. Oh wait, that's the same thing, because I didn't write this one down. All right, so let me restart this one. Sorry. I'm going to restart this one, because this is still going from atoms to molecules. And I want to go the other way. I want to go from moles to atoms. I didn't write this one down the other day when I was doing it. Okay. So, we're going to just start off again. Okay, let's redo that one. because I want to see show you guys how to read off your. So how, oops, this is not working. How many atoms are in 2.3 moles of oxygen? Okay. So here's my given. Here's my want. No grams, so no molar mass needed. Then I'm going to go ahead and write my given. So my given is going to be 2.3 moles of O2. Okay. Again, my want is atoms, so I need atoms of O2. My units of my given are moles of O2. And in 1 mole, there's 6.02 times 10 to the 23rd atoms. Okay. So these numbers are on top, so what am I going to do with them? Multiply them. So let's practice in our calculators. Okay. So I'm going to do 2.3 times 6.02 exponent, so second EE, 23, and press equals. Now, you should see a number come up with a little number up to the right. Did everybody get that? Okay. I just want to teach you guys how to read what it says, what you would write, okay? So if I was to write this one, I'm going to do 2 decimal points, so I would write 1.38, and you put times 10 to the 24th, because that's my exponent up here, 24, okay? So when you write this out, you would write 1.38 times 10 to the 24th, and my units, moles will cancel moles to leave me atoms of O2. Okay? So that's how you read those numbers when you get them off the calculator. Okay? Questions on that? Okay. Your practice today will take you between liters and moles, moles and liters. You will have 2 steps where you might go from grams to liters or liters back to grams. And then on the back side, you will have atoms and molecules practice. Okay? Okay? All right.